This is a two-part series that I am calling The Pursuit of Parsimony. In the first video, we'll talk about including and excluding independent predictors. Okay. The second video, we'll look at a different strategy which involves stepwise regression. The reason we do this is to try to identify an adequate and acceptable fitting model. Okay. So without further ado, let's begin. So as we look at a few guidelines to determine if we should include or exclude variables, something that should jump out is the t-value. In particular, we're looking at t-values that are high, which translates to a low p-value, which means significant. It means the variable is telling us something unique about explaining variance on the dependent variable, right? On this first guideline, as we assess, evaluate, is it less than 0.05 on that p-value? If so, if it's less, we want to keep it. But if it's greater than 0.05, we potentially consider removing it. On the second guideline, it says, well, if it's less than 1, should we remove it? If the t-value is less than 1, it's extremely likely we should be removing it. Okay. And what's important about that? When we remove a t-value less than 1, it will decrease the standard error. That's a good thing, right? So when we decrease the standard error, it increases the adjusted R-square. Good things happen. Okay. There's a note here that if it's a little bit more stringent if we set that at 2. And that shouldn't surprise us, right? So if we bump that up, we increase the threshold. If it's less than 2, we can tighten the model up, essentially is what we're doing. So make note of that, adjusting models. Number 3, the p-value and t-value over correlations. Okay. Typically, we adjust out multicollinearity in our VIFs in part 1, right? Before we get to this point. So the correlation has kind of already been trimmed at this point. So we're really kind of focusing on t-values and p-values and not so much correlation. Number 4, consider all or none variables that are part of a group. Okay, explore the partial f-test. It's not covered in this textbook. We won't cover it in our session, but know that if we have a group of variables, you want to try to keep them together. And I've incorporated into this video an example of that. Okay. And then this last guideline, have a basis and reasoning for a variable inclusion, right? So economic or physical theory. I would expand off of that, practice, intuition, not just because, but what makes sense in your industry. You get into the academia and research, you're looking for theory, but if you're in industry, we're looking at practice, okay? What makes logical sense? Okay, so I would say this, when we remove a variable, we have to be careful, and we need to do them at one at a time, right? And I want to revisit this because it's the phenomenon of the left foot, right foot. What does that mean? As I've said before, removing a variable can turn another variable to significant or may make a variable that was significant insignificant. Okay? So we have to be careful of that. And that's why we can't remove multiple variables when we exclude. Okay? So it's one at a time. All right. So as a walkthrough, this isn't your textbook. It's the catalog marketing file. Okay. And if you flip to, I believe it's page 4 491, 492, 493. It's in that area, right? Kind of walks through, gives them the background. At first, in this particular example, right? So there's 10 variables. So this is kind of the regression that was put out. And we can see several things if we kind of go through our guidelines looking at, okay, well, what's a low t value? What's the highest p value? Okay. This right here would mean we're a little bit more suspect that this marriage variable to explain if somebody's going to purchase from the catalog probably isn't a good predictor. Okay. So in the example, what was done, that variable was removed and it was assessed on these others because the rest of these are all significant, right? However, we got 1, 2, 3, 4 that are not. And so through an iterative process of removing one variable at a time and rerunning a regression and checking, look at the R-square, looking at how these other variables, if they flip right, so left foot, right foot, each process resulted, right? So each process resulted in none of them ever turning significant. And this was the end result after 4 different regressions, okay? So it's an important takeaway. The model went from 10 predictors to 6, right? And always important, interpreting what's going on with the coefficients, okay? And so this had to do with somebody's salary, right? So basically this says they were willing to spend 1.8% of their salary on catalog orders. They had children, they were less likely to spend, right? They're a previous customer. So all these things add up, and you can read up more about that in the write-up within the working example. But the main thing I wanted to highlight for you, right? It's an iterative process. So looking first at this t-stat, and what happened was we got a more parsimonious model, right? So doing much with little or fewer variables. We can still explain the variance. I didn't populate it and put it over here, okay? 0.745. So it didn't change a whole lot, okay? But the point being is with 6 variables, we're able to accomplish what 10 were. So that makes it parsimony. All right. So here's another example, the one that we've worked with here in the last session with the potential discrimination with salaries, right? Bank, right? So here's the data. Here's our coefficients. And so if we come over here and look at our p-values, most of these are significant. So as we kind of look at them, we could jump and say, well, what's the highest p-value? It's education 4. The rest of these are all less than 0.05. So should we remove education 4? Probably not, because it's part of a group. So that gets back into number 4 on the guideline. When a independent variable is part of a group, we try to keep them all together. Now, if we had, there's 5 in here, right? So the reference variable of 0, 0, 0. If we had, 3 of the 4 that are showing, giving us high p-values, we probably would consider removing the group. That's not the case here. This is just 1. So education 4 in this example, right? So make note of that whenever you have groups of variables. You may need to keep them if it's a large group and you only have one or a couple that shows insignificance. Okay, so very important to take away on that. So what are the key takeaways? The decision to choose a significant versus non-significant related coefficient is a strategy, right? It's one strategy. Make sure there's intuition, there's some type of logical sense to keep the variable in there or not. Okay. Number two, I put several of the statistical software's programs in there, right? We don't want to turn it into a fishing expedition. You're going to see that coming up. That's what stepwise regression somewhat does. Okay. We evaluate variables for a fit. However, we want to make sure that keeping one in or removing it is justified. Number four, when a variable is marginally acceptable, so say it's 0.051, or maybe it's on the p-value, 0.049, so it's marginally acceptably or not. Removing it in the regression equation probably won't make much difference. And so removal is discretionary. If you don't have many variables in there, probably want to keep it. If you have several that have a higher t-value, go for the higher t-values. And number four, when removing variables, do it one at a time. I can't emphasize this enough. You can't pull out, or you should not pull out multiple variables just because of the whole right foot, left foot phenomenon, right? So one IV at a time. Okay. Well, that concludes this part. Next coming up is stepwise.